All right, let's go ahead and find out how to speed up this process to calculate Newton's method. All right, so we need our function, and we just need our initial value. And we're going to tell the calculator to compute this for us. And all we have to do is, after we enter it in once, just keep hitting enter, 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 and get as many iterations as we need. Okay. So, the first thing we need to do is we need to store our first initial guess on the calculator. So what you're going to do is you're going to hit the -1 button, and then you're going to hit a button, the store button. Okay? The store button is located right above your on button. So if you're looking at your calculator, right above your on button, it says STO with a arrow. That's the button you're going to hit, and then you're going to hit your X button. You're going to tell it what variable are you storing -1 into. So if I hit -1, hit the store button, and hit X, it should look like this on your calculator. -1 with the little arrow X. Okay? As you can see mine. And then upon hitting enter, it just says -1. You have successfully stored -1 into your X variable. Now, we're going to do that anytime we want to change our initial guess. We have to store that value into our X variable. Now, we have to tell the calculator to do this. Okay? So, on your calculator, what you're going to do is you're going to hit your X button, and then minus, and then you're going to hit Y1, and if you recall how to get Y1, if you went through the tutorial, you hit vars, then you go over to the Y vars menu, and the very first option should be function, and then you should choose the Y1. We stored this equation into Y1. Choose that function and put it there, okay? And then you're going to do a parenthesis, X, close parenthesis. Then you're going to divide it by, and here's where you're going to use your n derivative, your numerical derivative. So, I'm going to put it in how my calculator puts it in, d by d with the box. So in this box, I'm going to fill it in with an X. It's going to have a parenthesis. Over here, I'm going to enter in Y1, close that, or the parentheses already closed, and then it has a little X down here is equal to, I'm going to say just X. Okay, so you just enter X in your calculator, minus Y1 of X divided by dx Y1 at X equals X. Now let me type that in on the calculator, and I'll show you what my calculator looks like. Okay. So, if you're looking at it, I got X minus Y1 of X divided by dx of Y1. I gotta scoot over. And then X equals X. Alright? So, if you don't have this on your calculator, everything will be the same, divided by, it'll say n deriv, parenthesis, you would put Y1, X, comma, X. Just like that. Now we've got one more step. We're going to hit the store button. So hit the store button, and then you're going to write X again. And same thing down here. You just follow that same step. So at the very end of it, I hit store X. The very end. So what this is going to do is it takes our first iteration, plugs it in to Newton's method, our first initial guess, minus the function evaluated at our initial guess. Remember, we stored -1 into here, divided by the derivative, depending on what calculator you have, of the function, oh, I forgot a 1 here, y1, of the function which we stored into y1, and then evaluated at x. And then it takes this answer and stores it into our second guess. Okay? Alright, so now that you have this entered in on the calculator, you just have to hit enter. Okay? Upon hitting enter, we get x2 is equal to -0.75, and then 0.0000417. Okay? That's what my calculator outputs, and if you recall, our second iteration was -0.75, -3/4. So as you can see, our calculator actually did do the full first iteration for us. Now, if you just hit enter again, it's just going to repeat the last thing that you just did. And if you notice, we get x3 is equal to -0.6825. Which is more decimals after that. But now, if you compare what we had here and our previous x3 when we did it by hand, you're going to see that they are identical. So this is the faster way of doing it on your calculator. And if you want more iterations, you just keep hitting enter. And it keeps going. Keeps going. And as you can see, it's getting closer and closer and closer. Actually, it doesn't change at all. -0.67765 or hold on, 6506988, and the next one it says the same exact thing. So that means this iterative method converged onto a root. If we were to take that value, so if we keep going, we get our root is x is equal to -0.67765. Okay? So I would recommend just keep doing it by the calculator. Get practice doing it on the calculator. Be careful entering it on the calculator with parentheses and whatnot. That's how we're going to do the second example. We're just going to solely do it on the calculator.